Hello and welcome to this V-bit inlay tutorial. In this tutorial we're going to take a look at a few different ways that you can create inlays by using V-bits. Now for the last few weeks I've been practicing this and trying out a few methods on my machine, and this was spurred by a group of guys in the Carveco Facebook group who have been doing these, and I've never done one, so I was quite curious about actually trying this out. So I'm using a really small machine, so I've actually set a few limitations for myself, which is I'm using a really small machine, so it's a SainSmart 3018 machine, so quite a small bed size. Can't take too much of a depth of cut, and can't obviously ramp the cuts up and get it going really fast. Also, I'm using a 90-degree V-bit. Now it would be easier if I used a 30-degree, let's say 15, 60-degree, whatever. Now I could have used one of those, but I wanted to use a 90-degree because if I can get this working using a 90-degree V-bit, I can get it working using any of the others. So this is what I'm going to do. So you can see that it's two inlays. So there's one inlay going over the other. Now don't worry about that. That's really easy. As long as you get the basics down with creating an inlay, you can do one over the other, you can do 7 over each other, it doesn't matter. Okay, so this is what I'm going to produce. Now if I close this and let's open up Carveco Maker, you can see that this is just a blank model. If I go to Toolpaths, and then down here we have Create Inlay Toolpath. Now don't get confused by this. This isn't for doing V-bit inlays. This is if you want to use an end mill, and what it does, it rounds the corners. So if you're interested in what this does, then I would strongly suggest that you take a look at the Carveco Fundamentals training on the website. Come down to the Toolpath section, and you'll see that there's an inlay video, and I'll go into a lot of detail about this and how it rounds the corners. Now because it rounds the corners, it's not very good for using the V-bit, and the whole point of using the V-bit is to get into some really tight corners and give you nice crisp corners. So let me close that. Now I also recommend that if you're new to Carveco Maker, not to follow along to this video, because this is going to be more for intermediate or advanced users. I'm already going to assume that you know the basics, and I'm not going to create the vectors, let's say for instance. I'm just going to deal with actually creating V-bit inlays. So let me close this and open up my model. So here you can see that I've got that design, and I've got two hearts, and I've also got this text. Now the text at the moment, I don't need to do that. I don't need to worry about that whatsoever. So what I'm going to do is select it, right click, and I'm going to move that to a new layer. So let's open up the vector layers, and I'm going to rename that, and I'll just call that Mommy. Now if I want to, I could give that a different colour. Let's say I want it to be blue. Okay, just so I know that it's on the different layer. And I'm going to switch back to the default layer and turn that layer off, because I don't need it at the moment. So I'm just going to deal with these hearts. Now to begin with, it's very easy. All that you need to do is a V-bit carving. So I can do them both together. So let's select all of these, go to my toolpaths, and then select Create V-bit Carving Toolpath. What I'm going to do with these is sort of a different method to what people have suggested, which is I'm going to let these go the full depth Okay, and I'm also going to use the bevel carving rather than the V-bit carving to do the male insert for these. So for this, let's select a carving tool. So I'm going to use, let's say, this one here, which is my 90-degree V-bit. And then click refresh. Now this is important because I need to know what the maximum depth is. So it's going to be 0.13376. So I'm going to write that down. Now, if you want to, you could round that up by limiting it to a maximum depth and just enter your maximum depth. It's entirely up to you. I'm just going to let this go the full depth. So if I click to define the material, let's say that it's 1/2 inch thick. My model position is at the top. So obviously set this up however your CNC is set up. Select OK. And then what I'm going to do is calculate now. And then I can close that. And let's take a simulation of this. So if I rotate around, move that out of the way and play. Okay, now if I double click on that, I can see here that this looks a bit jaggedy. Now the reason for that is because my tolerance, for some reason it's gone back to 0.025 inches. That's not the default tolerance. The default tolerance is 1 thou. So if I calculate that again and just delete that, and then simulate that again, it should look a lot better. Okay, so that's all good. All that I need to do now is save that out and send it to my machine to cut. Now this isn't a problem on my machine. It doesn't take very long to machine this because the V-bit's just going straight down to a depth. Okay, so this is a video of the hearts being machined. So you can see that I've got quite a small area to play with, and this video is massively sped up. So I'm just going around cutting the hearts using the V-bit, and it doesn't really take that long to do the female. Okay, so with the female done, I can delete this toolpath. Obviously save it before doing this. Delete that toolpath. And what I'm going to do is the left hand heart. I'm going to split these up onto different layers just so I don't get mixed up. So the left hand heart, I'm going to move that to a new layer. I'm going to call that left heart. The right one, right click, move to a new layer. And I'm going to call that right heart. And then I'm going to turn that right heart off and then make sure that I select the left heart. Now if I put that in the center of the model, my origin or my datum is in the center, and if I want to, I can rotate this around just so it looks as though it's all aligned. So let me go to transform. Let's rotate that around. I'll just do this freehand like so. Okay, so that's rotated around. This is the left-hand heart. Now, importantly, this is a mistake that I would say that most people who've done inlays have made. I made the mistake also and cut my first heart out, and I forgot to do this, which is mirror the part. If you don't mirror it, when you've cut the part out and you flip it over, it won't be in the correct orientation, so it just won't fit. So whenever you do the mail, you need to make sure that you mirror it. Now, I thought that I would get away with these hearts because I thought they would be symmetrical, but they're not. There's a slight variation. So I spent hours machining something and it didn't fit. So make sure that you mirror the mail. So to do that, really easy. Go over to mirror objects, and then what you want to do is go center, and I'll turn off copy. So if you go center, it's mirrored over. Now it's more obvious on text. This looks a little bit symmetrical, so you can't really tell, but you'll see later. So that's my left heart, and what I want to do first of all is explain that I'm doing a different method to what you would see on the internet, and a lot of people actually telling you how to do these. So the first method, I like it because it saves me time on the machine and it's really quick. Now, the only drawback with that is that it's only really good for single piece objects, because otherwise, let's say that I was doing a sentence, it would cut each piece out, and let's say that it was a long sentence, when you actually glue it together you would need like about 50 clamps or something to actually glue it together, so that's just not practical. So the only time that I would do this is really when there's just one or two pieces that I can glue in there. Okay, so what I'm going to do is just use these two vectors. So I don't need to do any offsets or anything. I'm just going to use these two vectors. And what I'm going to do is create a bevel carving toolpath. So the bevel carving toolpath is just the opposite of creating a V-bit carving toolpath. So let's select my tool. So again, make sure that you select the same tool. So I've got a 90-degree V-bit. Now, obviously, if I had a smaller angle on there, I would be able to get down deeper, and it would give me more to actually glue onto. But I'm not bothered about that. I've got it working using the 90-degree V-bit, and I'm happy with it. If I go down and use 60-degree, 30-degree, then great. It will give me more area that I can glue down, but I've got it working with a 90-degree, so I'm not too fussed about that. Right, so what I'm going to do is click center line. If I click the center line, it should give me the exact height of what the depth was when I created the V-bit carving. So if I click that, you can see that it's given me pretty much within a thou 0.134 inches. So that tells you basically the height of this that it wants to be. So if I set up my material, which is 1/2 inch, the finished depth, it wants to go 1/2 inch. So I'm just going to play around with this just to show you what actually happens. So if I calculate that, and let's rotate it round, and I'm just going to simulate this so you can see it. So what's happening here is that it's creating the V that I want, but the V bit's going right the way down to the bottom of the material. So if I rotate around, see how the V bit's going right the way down to the bottom of the material. I don't really want that. I want this V to be at the top of the material. So if I were to change, let's say, the wall height to, let's try 0.25. Now, what this is going to do, it's going to tell me that I need a profiling tool to cut it out afterwards. So if I select calculate, it says cannot calculate for the following reasons. You must choose a profiling tool, basically to machine the wall. So let's select a tool, And the tool that I used was this 1/8 of an inch Saying Smart tool. So click that, and I'm going to calculate it. So let's delete the simulation again, and then let's simulate that. So now you can see that it's moved it upwards, and then it's got a flat wall. Now this is really, really good, because it just means that you just need to do one cut around the edge, one cut around the inside, and then cut the part out. And it's a lot faster than using the area clearance or using the V-bit to do an area clearance, which takes a really, really long time. But sometimes you have to do that, and I'll show you how to do it in a moment. So this is a really, really quick method. Now the only problem with this is at the moment it's going a bit too deep. Now it doesn't really matter, since the maximum depth of this V down here will be the maximum width of the female that you created a moment ago. So this doesn't really matter, but I want it to be on the top. I don't want it to be all the way down there. So to do that, what we need to do is take off the 0.134, let's say, from 1/2 an inch. So I've got 0.366. So if I were to set that to 0.366 and then calculate that again, this is basically saying that there's not enough height. Now this means that there's going to be a flat on the top. Now I'm pretty sure that it's only going to be a fair or so for this, because I've taken the maximum height away from the finished depth. So I'm going to click yes, and then let's re-simulate that. So if I rotate around, now you can see that the bevel is on the top of the material. Now if I zoom in, you can see that there's just a small section that's flat there. Now if I were to actually machine this and try to place that into the female, this would be pretty much size on size, and I don't really want that because I need somewhere for the glue to go. So you need to have a little bit of an area underneath it that the glue can go, and then it can butt out. So if you make this wall height larger than 0.366, then it will add whatever that is as a flat. So let's say that I want it to be 0.4, and then calculate. It will give me the same warning message saying that it's going to be truncated. Now, as I said, it just means that there's going to be a flat on the top, which is exactly what we want, because when we fit the part in, I need that area underneath it. So now, if I delete that simulation and simulate again, you can see that I've got this flat. Now that's perfect, so that will fit into the female that I've created. Now if you want to make the flats larger, let's say 0.45, it doesn't really matter what you use. You just need to be aware of how much wall that you've got on there. Now the good thing about this is that this is actually how it looks. So this is how it's going to fit into the female. I know that this is the exact size, so I know how much of this wall is going into the female. So if I calculate that now and say yes, and then delete the simulation and simulate that again, now you can see that there's only a little bit of the sidewall, so I've probably gone a bit too far there. So I'm going to bring that back. Let's bring it back to 0.4 and calculate. So if I delete that and simulate again, you can see that I've got my flat. So you can just tweak these, but as long as you got a bit of a flat there, and there's somewhere for the glue to actually go, then you're going to be all good. Now, the drawback with doing this is that this is exactly the size that you want. So if for any reason that it's not cutting correctly, let's say the bed's out of square or something, then you may have little gaps. So maybe you haven't clamped it perfectly. You may have a little gap around the edge. So on the next heart, I'll show you a different way to do it so you can add more of an angle onto this. But what we need to do is cut this out. Now, if I were to cut this out on my machine, this would be flying all over the place. So the good thing about doing this also is that you can add bridges. So if I add bridges, and let's say I'm going to do 1/4 of an inch, thickness, let's say 0.1 inches. Let's do 2D bridges and select add. Now, if I turn on my vectors, this is something that you need to watch out for. If you try to do this and select add, what it's done, it's actually added these to the center line because I've still got the center line selected. So what I'm going to do is just turn off those. Let's delete the simulation and make sure that you select the outside edges. Okay, so if you've still got this center line on there, it will select the center line and it won't create any bridges. So let's select add, and it creates these bridges. Now, to be completely honest with you, I don't care where these tabs are or bridges are. So I'm just going to calculate, select yes, let's simulate it again. Okay, and you can see that it's left all these tabs on. Now, the reason that I'm not bothered about that is because when this is turned over, flipped over, I can just cut these out just using a knife, and I don't really care about the back edge of this because this is all going to be machined back down, and I've got lots to machine off there anyway, so I'm not too fussed about that. So let's machine this. So here you can see it's doing 2 cuts for the V-bit. Now, this is the reason that I like doing this rather than using the V-bit carving and letting that do an area clearance. This just comes straight down to the depth that you want it to do, and it saves so much time with machining. Now, if you've got a fast machine, then you could just do the method that pretty much everyone does, which I'm going to show you in a moment. So that's the V-bit carving, and then just cutting the part out. So this just going straight down to a depth. It saves me having to do an area clearance, which takes quite a long time when you're using a really small tool. Okay, so that's finished. Let's lift it up. Let's take a look if it's cut through. Okay, perfect. So I can just clean that up, cut it out, and then we'll see in a moment what it looks like in the female. Okay, so let me close that bevel carving, and I'm going to delete the simulation. And I'm going to leave the bevel carving, and I'm going to use the same toolpath on the right heart now. So if I take a plan view, and I'm going to right click on right heart on the light bulb, turn on my vectors, and you can see that I've still got my toolpaths here. Let's turn those off. And I'm going to select that right heart, press F9 to put that in the center. Let's transform it around like we did before, like so. Importantly, I haven't done it on this one. I need to mirror. So I'm going to go center, Now this is entirely optional. What you can do is make the bevel come down further. So when you actually glue it in, it's not at the exact point. So to do that, if you're using a tool other than a 90 degree, then you'll have to work it out with a bit of trigonometry. Now it's very, very easy. Here you can see that I've worked it all out for a 30 degree V-bit. So whatever the depth that you want to make it larger, all that you need to do is do tan whatever the degree of the tool is. So here I've got a 60 degree V-bit, so 30 aside. So tan 30 times by the depth that you want to go deeper, which is in this case 1/8 of an inch. And that works out to be 0.0722 inches. So that's how much you've got to offset it. With a 30 degree tool, then it would be tan 15 times by the depth that you would want to basically go down deeper. So if it's, let's say, 1/4 of an inch that you want it to go down deeper, tan 15 times 1/4 of an inch, and that will give you the answer. So it's always the same formula. It's pretty easy once you get the hang of it, and you just know that you've got to use tan to work it out. With a 90 degree V-bit, it's really easy because whatever I offset it, it will come down by that distance. So if I select both of these and select offset, and I'm going to do it by, let's say, 80 thou or 2 millimeters, select offset, and it creates that offset. So now if I open up the same bevel carving toolpath, and I'm going to select that one and that one, click center line, and you can see that the maximum height now is 0.225. So let me just calculate this for the time being. Let's just see what it does. So let me simulate the toolpath. And you can see that it's done the same thing, but it's given me a larger flat, and you can see that it's wider. So what I need to do is, rather than have this wall height, what I can do now is take the 0.225 off 0.5. So if I were to make it, let's say 0.3, and then calculate, you can see that I've just got this small amount of flat. Okay, and this is a lot wider. So if I were to make it, say, 0.35, so this is going down a little bit deeper than it did before. Delete that and simulate again. So you can see that it's added the flat and it's a lot wider. Now if I take a plan view of this, and let's turn off that toolpath and turn on my vectors, so you can see here these two lines are the original lines that I created. So you can see that it's coming past, and you can see that it's making a much wider bevel on there. So when I actually glue this into the piece, you'll be able to see it actually come out of the piece, rather than the previous one that we done, the left-handed one, which would just stop at the width of the female and then just come straight out. Okay, so let's make sure that we've got the bridges on here. So it's done exactly the same thing before as before. I selected the center line, so that's something that you need to watch out for. And I'm going to select add and then calculate again. So let's delete the simulation and let's simulate that. Okay, so that's all good to go, and I can send that to the machine and start machining. So here you can see doing the V-bit. And you can see that it's left a little bit more of a flat on the top of there. So if I just clean this up and take a look at it, you see it's gone through the material, and you can see that there's a little bit more of a bevel. Now you can see with both of those in there that the left-handed one is pretty much flush with the top of face of the chopping board. The right-handed one, you can see that there's a gap underneath. The reason being is that this one comes out a little bit further. So if there's any discrepancies with, let's say, when you actually cut the chopping board or chop the female, then this comes out a bit further and you'll get away with any discrepancies. So this is just machining the back off of the hearts once they're all glued down. So just clamp them all up, glue them down, and then just machine the backs off both of them. Now this takes quite a while on this particular machine because I'm using quite a small tool and I can't set the feed rate too high. Now also, I've not leveled the bed, so I haven't got a wasteboard on here and the bed's not perfectly flat. So what I've had to do is come down as far as I can and then just sand the rest off. Okay, so that's one way to do it. So using bevel carving toolpath. Now, this isn't really that good if you're doing, let's say, text or something. So if I were to delete this, let's delete the bevel carving as well. And I'm going to go onto my text layer. So let's turn that on. Okay, so now I'm going to machine this by using a V-bit carving toolpath. So create V-bit carving toolpath, and I'm going to click to select a carving tool. So let's use this 90-degree V-bit carving tool. Click refresh. Now you can see here that the maximum depth that it wants to go to is 0.18 inches. Now let's say that I don't want it to go down this deep, I just want it to be at a set distance. Now if you had a less of an angled tool, so say 60 degree, 30 degree, whatever, then the maximum depth would be a lot lower because the tool would be able to get in there. So because I'm using the 90 degree, it's not really going in that much, but I'm not too fussed about it. What I'm going to do though is limit the tool to a maximum depth. And I'm going to give the maximum depth of this 0.15 inches. And I'm going to write that down because I'm going to need it in a moment when I do the male or the plug. Now I'm going to use a roughing tool for this as well, so I can just get rid of most of this material. So if I click roughing tool, let's use my 1/8 of an inch Sane Smart tool. And what I'm also going to do with this is add a little bit of allowance. So I'm going to do that at 0.02. So I'm leaving 0.5 millimeter on there. So if I click calculate now, and then let's simulate, let's say, the roughing. Okay, so that gets rid of a bit of material, and then simulate the V-bit. Now you can see that it's left this area here standing proud. So I'm not really too fussed about it because it's probably not going to be high enough because the part that I want to fit in there isn't going to fit in that bit anyway. But let's just sort it out. So if I go to the 90 degree, and you can see that that's caused by the step over. So let's make it, let's say, about 10 thou and calculate it. So if I delete that simulation and then simulate the V-bit carving. Okay, and you can see that it's stepping over and it's scoring all of that. Now, I'm not too fussed about the finish on there because no one's going to see it anyway. Okay, so that's the female done. And what I need to do now is save that, send it to the machine and get it machined. So here you can see it's roughing out all of the portions that it can get into. And then finally doing the V-bit carving. Now, to do the females of these, it's really, really easy. There's no hard work in those whatsoever. And you can see that I'm actually doing a female, and this inlay is going over the top of another inlay. So literally approach it exactly the same way. So once this is done, the first inlay, you can just do another inlay and just machine it over the top of it. So see how the M there is going through these hearts. Okay, so that's what it looks like when I take it off the machine. And you can see that I've actually added a little bit more of a flat here. And the text must have been a little bit wider when I actually done this. So onto the male, or the plug that fits into this. So if I delete the simulation, and I'm going to delete the V-bit carving. Now I need to make sure that I've still got my size right down, which is 0.15. That's how deep this is going. So let's delete that. Turn on the vectors. Let's take a plan view. Now what I'm going to do with these, because I'm just cutting it out of another piece of wood, is I'm going to press F9, put that in the center, and I'm going to flip that over. So I need to mirror this. So this is where you actually see the difference. So if I go center, you can see that it's mirrored it. So now what I need to do, to create this, I'm going to show you what not to do. Okay, so this will take ages. It would take me hours and hours to machine this. So if I draw the box around that, and then I'm going to select all of this, and I'm going to do a V-bit carving toolpath. Now this works, but it's going to take a long time to do it. So create a V-bit carving toolpath. And then what I'm going to do is I'm going to turn off limit tool to maximum depth for a moment. Select a carving tool. So I'm going to use my 90-degree V-bit. And I'm going to click refresh. Now this is going to be huge. So this is going to be a maximum depth of who knows. So maximum depth of almost 1 inch. Okay, now let's say my material, let's set that up again. Let's say it's 3/4 of an inch. And select OK. Now obviously that's going to go through, so I need to limit this to a maximum depth. Now if I were to set the maximum depth to, let's say, 0.5 and calculate it, simulate that, let's take a look. What does this do? Okay, so it gives me that. Now if I take a plan view of that, turn on the vectors, you can see what's happening is that it's creating pretty much what I want. But the trouble is that the size here is the same size, or the width here is the same size as what's on the female. So it's not going to fit. So what we need to do is drop this size down a little bit. Now the way that you can do that is to add a start depth. So if I were to add the start depth of, let's say, 0.05 inches and click calculate, and then let's delete that and simulate it. And what it's done, it's taken more off the wall. Now, I appreciate that this is really, really hard to see, especially when you're just doing stuff in 2D and actually see it. But if you set this start depth, it takes more off the wall. Now, the maximum depth is obviously the maximum that you want it to go to. Now, you don't need it to go that deep. You just need it to go deeper, just slightly, than what you set it in the female. So in the female, it was 0.15. Now, what we can do here is have the maximum depth at 0.15. Now, what this does, it actually adds the start depth onto the maximum depth. Okay, so even though it says maximum depth is 0.15, the overall depth and the actual maximum depth is 0.2. Okay, so if I were to calculate that now, and then delete the simulation, let's take a look at it again. Okay, so it's only coming down so far. Now, obviously, I don't want all of these bits. So what I would do is add a roughing tool. Click calculate. Let's delete the simulation and simulate again. Now, one thing to watch out for is once you set this roughing tool allowance, it stays like it. Okay. So the flat that you've got here, that's basically where it's taking off more material. So this doesn't look like the female because the female came straight down to a point on all of these areas here except for the bottom of the M. So if you've got that flat on there, you know that it's going to fit in there and you're going to be able to glue it in there. Now, all that you need to do is make sure that you've got your maximum depth. Now, you can set it. You can see that I've got the maximum depth as 0.15 and I've got a 0.05 start depth. So the overall depth is going to be 0.2. So that's 0.05 longer or larger than the depth of the female. If you want it to be even more, then you just change your maximum depth. So if I were to set that to 0.2 and then calculate, delete the simulation, let's simulate again. Okay, and there you can see that it's coming out a bit more. Now, don't worry too much about this. This is what's been left on by the roughing on there. So if I were to make that smaller, let's say I left 5 thou on there and calculate it. And then simulate again. You can see that I've got less in there. Now, as you can see, this toolpath is going to take absolutely ages for me personally. And that's why I like to do the bevel carving, because this area clearance here, let me delete the simulation. And let's close that. And I'm just going to turn on that light bulb. This area clearance here is going to take me absolutely ages. This is going to take me hours and hours. So what I would tend to do is offset the vectors. So to do that, let's take a plan view, turn off the toolpaths, turn on the vectors again, and then I don't want to use that. Let's delete it. I want to select all of those and offset. Now I can offset a specific distance. What I'm going to do is just grab them and I want to make them all as one entity, sort of like that. So let's close that. And then what I can do is, let's delete that. I'll just let it machine inside here. Select all of those, refresh. So the maximum depth now is only 0.21 anyway. So if I calculate that now, and then let's simulate the roughing, you can see that it's a much shorter toolpath. It's going to take me a lot less time than it did before. So let's simulate that toolpath. See, that's the roughing, and then let's simulate the finishing. Okay, so that's going all the way around there. Now what I can do is cut the part out. So if I close that, take a plan view, turn on the vectors. Now you can see these vectors. I just want to reiterate that this is inside. So that's because of the start depth. If I didn't have start depth set, this flat would be coming out to the edges. Okay, so you can see that it's taking a bit more off. Now what I need to do is cut this out, but I need it to follow this path around here. And I'm not really going to be able to do it because when I try to fit this into the other half, if I've got any bits that are sticking up, it's not going to fit. So what I need to do is actually offset this a little bit more and do the area clearance on that. So if I were to select that and then offset again, and I'm going to make it about there. Now I know that some of this will be wasted machining, so one of the reasons that I don't like doing it this way, but just showing you different ways that you can do this. So if I don't select that outside or the middle one that I've got there and select the outside and calculate that now, and then let's simulate this. So you can see that's the roughing. Simulate this. That's the finishing. And then what I'm going to do is turn on the vectors again. Let's turn off the toolpaths. And I'm going to use this as basically my cutout. Now what I need to do is if I zoom in and hover the mouse over the edge of this, and if I hover it over there, if you take a look down the bottom right hand side of the screen, you see a Z height. So the Z height for this is minus 0.21. Now you need to make sure that that is correct. So as long as it's over what the female is, which is 0.15, then you're going to be all right. So just make sure that you don't cut this out and actually cut it out and not leave enough of the angle on there to actually fit. So let's cut this out now. So I'll just use the same tool, do a 2D profile, finish depth 0.75. Let's go outside, select a tool, choose my 1/8 tool, and I can add some bridges to this if I want to. Let's add. Now, I'm not really fussed where they are because, as before, I'm just going to cut them out the back. Now, maybe that one there I might want to move, so let's edit that. Just move it around to that M. Okay, and apply. And then I can just calculate that. So let's simulate that as well. So there you can see it's cut it out. Okay, so when that's cut out, you can fit it in. So let me show you that machined, what I actually done. So here you can see all the roughing. I've done this out of a bit of hardwood flooring that I had lying around. So, and then you've got the V-bit going round, cleaning it all up. Now this still takes a little while on this machine. especially as it's machining, say, the back, and I don't really need to machine the back. So then finally just cutting the part out. So taking it off the machine, you see it's cut right the way through. And you can see here that it's just sticking out just slightly. I just need to glue this up now and then wait for it to dry out, and then I can get it back on the machine. Probably overdone it with the glue here, but better to be safe than sorry. And then once it's dried, I can just do an area clearance going around the whole thing just to bring it down. Now, as I said before, my machine's not flat, so I could only come down so far, and then I had to sand the rest on. But then once you have done that, you'll be left with a nice looking inlay. Now, as I said before, don't worry about an inlay going over the top of another inlay. It doesn't really matter. So you could have an inlay within an inlay within an inlay, if you like. All that you need to do is do one inlay at a time. Now, one thing that I forgot to mention is when you do this V-bit carving on the mail, the start depth here. Now, because you're telling Carveco Maker that your start depth is 0.05, it will automatically plunge down to this point and think that this is okay. So your first cut is going to be 0.05 plus whatever your step down is. So just bear that in mind. So this was a little bit hard for me on my machine because that first cut and the step down was really quite a large cut for me. So I had to slow the machine right down and hope that it went through it okay. So that's just one thing to bear in mind. If you've got a faster, larger machine, then not to worry about it. Just make sure that you know that it's going to go a bit deeper on that first cut. So what people tend to do, the sizes that they tend to use are normally start depth 0.05, just to take it in a touch, and then the maximum depth, you can set that to pretty much whatever you like, really. It just depends on how deep you actually want it to be. As long as it's touching on the sides and you've got something to actually glue onto, then you can pretty much use any sort of size that you want. So I hope that you found this tutorial useful. I hope that I didn't go off on too many tangents, and hopefully we'll see some really nice V-bit inlays coming soon. Okay then, cheers, take care, bye.